Hello and welcome. In this lesson, we will talk about a very important thing, which is numbering systems. As most of you know, there is a lot of numbering systems, including decimal, hexadecimal, binary, and octadecimal. Today, I will talk to you about decimal, hexadecimal, and binary. Let's start a new project. Choose any bit. Let's say that we want 16F4. Next, finish. Now, in micro C environment, the default numbering system is decimal. So, if I wrote or defined a new variable, let's say integer a equals 0, this means that the variable a has a decimal value of 0. If I want to write it in hexadecimal, I must define that I want to use hexadecimal by starting with the 0x 00. This means that I'm using hexadecimal, as you can see here. If I want to write the number in binary, I must write this prefix 0b, 8 numbers. Now, why do we have here 2 numbers while here 8 numbers? This is a binary number, so each hexadecimal number has an associated 4 binary numbers. Now, if you want to see this in action, micro C environment provide a quick converter. So if we wrote 0 here, it will equal 00 in hexadecimal, and it will equal 8 zeros in binary. So this is a very easy way to do this. If we wrote 8 ones, as you can see here, it equals 255, and it equals in decimal, and equals FF in hexadecimal. So you can use any of these. As we said earlier, the default is decimal, so we don't need a prefix for the decimal system. But if in case of hexadecimal or binary, we need 0x for hexadecimal, 0b for binary. This is a really important thing that you must take into your consideration. Now, if I wrote 4 ones here, as you can see, 4 ones equals F, and in decimal equals 15. Now, how can we convert from binary to decimal? I can show you a quick explanation on how to do this. Now, let's say that we have 1, 1, 1, 1. These are the 4 ones that are written here. In order to convert this into decimal, we must write the value of each bit. 1, 2, 4, 8. Now, 1, 2, 4, 8, 16, 32, 64, and go on. 4 ones means that we need to sum 1 plus 2 plus 4 plus 8, which equals 15 here. Now, if one of these numbers is 0, we will cancel the associated value. So we will sum 1 plus 2 equals 3 plus 8, it will equals 11. As you can see here, only the one with ones must be calculated. Let's write 1101 here and see if it will equal 11 or not. As you can see here, it equals 11, just like we stated here. It's a really simple method. You just need to write 1, 2, 4, 8, 16, 32, 64, and assign ones and zeros. Okay, that's it for the numbering system. I recommend using the quick converter since you won't have to do this process, but you need to understand how this is done. You can choose to use decimal, hexadecimal, or binary. In case you want specific control of port bins, you will need to use binary since it allows you to control 8 bins. So if we stated 1 here and 1 here, this means that we are controlling 2 bins of the board. the same can be done here and here, but this gives you a flexibility in handling numbers. That's it for now. We will implement this very soon. Thanks for watching. This is Education Engineering Team.